Welcome to the Unit 5 Lesson 3 notes. For these first 4 warm-up questions, I want you to pause the video and work them out. Make sure you're paying attention to your order of operations. Do whatever's in the parentheses first, then multiplication and division from left to right, then addition and subtraction from left to right. So go ahead, pause the video, work them out, unpause it, come back to see how you did. So for number 1, the first thing we have to do is going to be what had just happened? I don't know how I managed to do that. Must have bumped something with my hand. All right, so for number 1, we have to do inside those parentheses first. 4 plus 6 is 10. My next step, I have to do the multiplication to get 30 minus 10. And my last step, I just subtract to get 20. For number 2, inside that parentheses, I get an 8 times, and then I can also just do 4 minus 1 in its parentheses as well. Okay, the parentheses happened first, so everything had to happen inside those parentheses first. Next, I'm going to multiply. 8 times 3 is 24. And then 24 divided by 4 is going to be 6. For number 3, I have 5 plus 14 minus 6 is 8 times 3 plus 2 plus 3 is in parentheses. I can make that a 5 inside those parentheses right away. Next up, I have to do the multiplication. The 8 times 3, which is 24. So then I get 29 plus 5, which is 34. And for number 4, I have to do inside the parentheses first. So 27 minus 19 is going to be 8. And then I have to do the multiplication next. 2 times 3 is 6. Now I basically just add. So 6 plus 6 is 12. 12 plus 4 is 16. 16 plus 8 is 24. So today we're going to be talking about expressions with exponents to round out the full order of operations, which is going to be called PEMDAS. All right, so I'm just going to get all 4 of these up on the screen right away. Step 1, the first thing we always do is look for parentheses. If there are any parentheses, we have to do what's inside of those first. Okay, and then basically, once we're inside those parentheses, we start the process over and say, are there any parentheses? If there are, we start over again and keep doing that as many times as we need to. Once we're done going inside of parentheses, next thing we are going to do is exponents. Once we finish all of the exponents, then we are going to do all of the multiplication and division, but they have to happen in order from left to right. And then after that, we do addition and subtraction again from left to right. So the first example we have here, well, I almost forgot the most important part. I said it's PEMDAS. You can also use the phrase, please excuse my dear Aunt Sally. That's a math teacher's favorite. I say that because my math teacher had us repeat this so many times that I say it as, please excuse my dear Aunt Sally. But when I refer to my parents' sisters, I refer to them as my aunts, not my aunts. So please excuse my dear Aunt Sally is stuck with me so much that that's exactly how I read this sentence, even though I don't usually pronounce aunt as aunt. All right, so you need to know this order. It's going to be huge. But this first example, there's one part that I don't really like about it, and I'll cover that once we get to that. So the first step we do is we look for parentheses. Are there any parentheses? The answer is yes. So I just rewrite everything else. That parentheses becomes an 8. All right, so now I ask myself again, are there any parentheses? I have these, but there's nothing happening inside of them. So I say that there's not any parentheses, and I move on to exponents. This is the exponent. I do not like this as the first example because what an exponent is and what students make mistakes with are not the same thing, but with this example, you get the same answer. All right, so 2 squared is 4. Typically, students say, oh, that's 2 times 2 equals 4, but that's not how these things work. If I had 2 to the third, that does not equal 6. Okay, 2 to the third just means 2 times 2 times 2, which is 8. All right, so we were saying there are 1, 2, 3 2's. All right, this works for any other number as well. I already have something over here by accident. If I had 3 to the 4th, this is 3 times 3 times 3 times 3, which is going to be 81. We are multiplying this number, which is called the base, by itself that number of times. So it's not 3 times 4, it's 3 times 3 times 3 times 3, and there were 4 3s. So again, back to this example, the reason I didn't like it is because if you do the exponent times the base, you get 4. If you do the base times the base like you're supposed to do, you also get 4. So you might get lucky sometimes that making a mistake and still having it work out in your favor. All right, so for this problem, since we have to do that, we would have 2 squared is 4. We go left to right with multiplication and division next because there's no parentheses and no more exponents. So I have to do that piece next. And then I do the division piece to get 4 plus 4. So I get a final answer of 8. If you do not do this in the correct order, you're going to get a different number. The order of operations is like the law of the land. You have to use that order of operations in order to do the problems correctly. All right, so for this one, first thing we ask ourselves, are there any parentheses? The answer is yes. So I write everything else exactly where it was, and then I do what's inside the parentheses. 15 divided by 3 is 5. Okay, next up, do I have any parentheses? These parentheses don't have anything happening inside of them, so I say no. I move on to exponents. Yes, there's exponents right there. That is 4 squared, which is 4 times 4, or 16, minus 5 times 2. I took off the parentheses because they're not really useful anymore. If you want to leave them on, that's perfectly fine. It doesn't change anything. Next up, I have to do check for parentheses. There are none. To check for exponents, there are none. So I do multiplication and division. So I've got 16 minus 10, and then I just subtract and get 6. Now this one has a couple of little tricks in it. So I look for parentheses first, and I have parentheses, but inside that parentheses I have 2 different operations. I have addition and I have exponents. Inside those parentheses I need to restart the order of operations. So inside that group of parentheses I check for parentheses. There are not any, but there are exponents. So I actually do 5 squared first. 5 squared is 5 times 5, which is 25. Okay, and I'm still inside the parentheses. So now I can have 27 divided by 9 plus 7 minus 2 times 3. All right, so no more parentheses, no more exponents. I do multiplication and division from left to right. 27 divided by 9 is going to be 3. 2 times 3 is going to be 6. So I now just add and subtract from left to right. 10 minus 6 is going to equal 4. Now I've got a couple of reminders of algebra tiles quick before we actually do some more problems, just to make sure we remember how to add and subtract negative numbers. So if I want to use algebra tiles, we draw a positive tile and a negative tile. These slides, I use red and yellow squares. I usually just do like an open square for positive, and then I color it in for negative. If you wanted to do it the other way around, where colored in was positive and open was negative, that's fine as long as you are consistent. So to represent 1 plus negative 3, which is the same thing as 1 minus 3, I would put in 1 positive square, and then I have 3 negative squares. So I'm going to color in 3 squares. I don't even have to color them in super nice. I just have to make sure I know they're shaded. Every group of a positive and a negative cancels out. And then we have 2 squares left, and they're both negative. So my answer to this question would be negative 2. That's how we use those algebra tiles if we're needing help when we're supposed to add negative numbers. All right, so they just stack them up vertically instead of horizontally like I did. That's totally fine, because I get the exact same answer. Now, for the work that you're going to do right now, activity 1, all you are doing is circling the thing you would do first. You do not have to solve those. Just circle the thing you would do first. Activity 2, you are going to evaluate that whole thing using PEMDAS, using the order of operations, to get an answer. Make sure you're showing each step throughout the process so that we can find out where you made a mistake if you do make one. All right, so pause the video. Activity 1, circle it, the first thing you would do. Activity 2, actually answer them. When you're done, unpause, see how you did. So for number 1, the thing I would do first, I always look for parentheses, and there are parentheses, so I do 2 plus 7. Number 2, I look for parentheses, there are none. I look for exponents, there are none. Then I do multiplication and division, but I go whatever happens furthest left first. So 8 divided by 2, not 2 times 1. Number 3, I look for parentheses. That was an easy one. Number 4, I look for parentheses, but I had to jump in a little bit more because inside the parentheses there was an exponent and a subtraction problem. So I have to do the exponent part first. For activity 2, the first thing I'm going to do is the parentheses. Next I have to do the exponents. Next I multiply. Now if I take 9 minus 56, I'm going to get a negative number. I'm going to get negative 47. So this gives me a negative 51 overall. For number 2, I have to do the parentheses first. So that's 16 plus 28 divided by 2 squared times 3. Next I have to do the exponents. I don't like this set of exponents, but I don't really get a choice in that matter. Next I have to do multiplication and division from left to right. So 28 divided by 4 is 7 times 3. 7 times 3 is 21. So together I get 37 for an answer. And number 3, I have to do inside the parentheses first. There are 2 sets of parentheses. So I can actually just do both of them at the same time because they're not interacting with each other at all. Next I'm going to be doing, I almost forgot that negative sign. Next I'm going to be doing multiplication. So I got 48 minus 12 minus 12. That's going to be 36 minus 12, which is 24. Excuse me. For the problem solving part, we're going to do a little bit different than what it says. It says in each problem, an attribute of a three-dimensional shape is given. Sketch a picture of the shape that has that attribute and one that does not have that attribute. Compare the 2 shapes and explain how that attribute makes the shape look different. Use as many of the new vocab terms learned in Lesson 3 as possible. We didn't really talk about any in Lesson 3. So we're just going to kind of say what these things are. So vertex, that's like a corner of a box. And parallel bases, remember the base is like the 2-dimensional shape that's usually at the bottom. Okay, parallel bases mean they are the exact same shape on top and bottom. They would never touch each other if you were to extend them out forever. So think like the top and bottom of a shoebox. What we're going to do is I'm going to draw an example for each of these, and then I'm going to have you try to draw an example as well. It's going to be a little bit tricky because drawing 3-dimensional shapes is challenging, so I want us to practice on being able to do that. So you can pick whatever shape you want. I will pick some shapes. You could pick a different shape. Our explanations should be similar, but they might be entirely different just based off of the thing we focus on. So if I want to draw a shape with a vertex, I'm going to pick any shape that I want to that's got a corner. I'm going to pick a cube. Okay, so a cube, I'm going to start by drawing the base. Okay, so that was my attempt at a square. To draw my base, my parallel base, I'm going to put a dot right in the middle of the square. I'm going to put a dotted line going over to the right, and a dotted line straight up from that dot, and then I'm going to finish making the square. If I was perfect, this would be the exact same shape as the first one that I drew. Next, I'm going to connect the top left corners together, the top right corners together, the bottom right corners, and then the bottom left I'm going to connect with the dotted line. Remember, those dotted lines are supposed to represent hidden lines that we would not be able to see if this was, in fact, a 3-dimensional shape. The vertexes or vertices would be these 8 corners. If I want to draw a shape that does not have that, I need to draw a shape that does not have any corners. So basically I need to draw a ball. I'm going to draw a sphere. To draw a sphere, start by drawing a circle. And then inside that circle you're going to draw basically an oval with part of it being dashed. It's not the greatest, but it works. So explain how this makes the shapes different. Okay, well, if it's got a vertex, it needs to have a corner. So if it doesn't have a vertex, it could not have a corner. It's got to be round. So I want your explanation. It's got to be something related to number of vertices, number of vertexes. For number 2, parallel bases, you could draw a cube again. I'm going to draw a triangular prism just to be different. So just like before, anytime we're drawing a prism, that's the fancy name for these, you're going to start by drawing the base. I'm going to draw my base as a triangle like this. Try to draw a better straight side. There we go. Just like before, I'm going to put a dot. Typically, I try to go in the middle. Since we have this slanted part, I'm not going to go in the middle. I'm actually just going to go a little bit past it. And then that same dotted line to the right, dotted line up, and then I can connect these corners. Because I would be able to see that piece right there. I'd be able to see that piece right there. I would not be able to see that piece. So my parallel bases are these triangles. It's the front and back of a box. Not a very useful box, but a box nonetheless. If I want to draw a shape without a parallel base, generally that means we're going to draw a pyramid. So to draw a pyramid, I'm going to draw a triangular one this time, just to be different. So I'm going to start by having my triangle look like this. But what I should have done is I should have picked those two sides to be dotted, because I'm not going to be able to see them. When I'm drawing a pyramid, after I draw this base, I go basically straight up. And what I'm going to do is I'm going to kind of cheat a little bit to the left and just put a dot. The reason being is because I want to connect that dot to each of the corners. And this one, it would be dashed. If I didn't cheat a little bit to the left, I'll show you what that would look like. If I went straight up and put a dot right there, this part right here gets kind of hard to see. So by cheating it over to the left, you actually can see that it is a triangle on that side. All right, so how are these shapes different? Well, if it's got parallel bases, that means it has two bases. If it does not have parallel bases, generally that means we only have one base, or we all come up to a vertex, come to a point. All right, so make sure you're working on your lesson 3 homework. Hope everybody has a great day.